You can find the distance between two ordered pairs, 2 points, on a graph by using the Pythagorean Theorem. And to recap, here are our steps so far. You're going to be given 2 ordered pairs, just like down here. See them? 1, 2. Step number 1, we're going to plot both of them on a graph. If you don't have a graph, you can draw a graph, or you can ask for a graph. Then you're going to connect the points, connect the dots. Once your dots are connected, you're going to draw the right triangle. And it says right here, stay on the streets. We're going to look to see what that means. Alex, put it in the recycle bin. Then you're going to count the leg lengths, which are A and B. And you're going to solve for the hypotenuse. You're going to solve for the hypotenuse. A squared plus B squared equals C squared. We've been doing a lot of that this week. And here's why we have to go through this. So, 3.9. Step number 1. Plot both points, right? 3, 9, and negative 5, 4. I'm going to go over 3, and I'm going to go up 9, and put my dot. Then I'm going to plot negative 5, 4, negative 5, 4. Plot both points. Done. Step 2, connect the points. I'm just going to try my best. Doesn't have to be perfect. But the reason I have to use the Pythagorean Theorem, because I'm trying to find how far apart these two dots are, right? But you can't count because it's a diagonal. If I look, this is not 1, and this is not 2, and this is not 3, and this is not 4, because those measurements go horizontally and vertically, and this is a diagonal. So since I cannot just count it with my eyes, I've got to use the Pythagorean Theorem. So step number 1 is to plot both points. Step number 2 is to connect the points. Step 3 is to draw the triangle, and it says stay on the streets. And I'm going to do this in pencil so that I can erase it. What I mean by stay on the streets is go straight up and down, vertical, and straight side to side, horizontal. That's what I want. Some of us, when we make a triangle, you're going to be like, you need to make a right triangle. And in order for it to be a right triangle, it has to be perpendicular, 90 degrees, which means that it's a vertical and a horizontal edge. Because look, right there in the corner, there's your box already. You have to make it on the streets. You cannot be like, make a little side trip in the middle of your drawing of a triangle. Yes, so we just had a good question. Instead of having your dots go like down and then this way, you could draw it going the other way too. It doesn't matter which way you go. It does matter that you're going straight in a vertical line and in a horizontal line. Step number 1, plot the points. Did it. Step number 2, connect the dots. Did it. Step number 3, draw the right triangle. Did it. Step number 4, count the legs. 1, 2, 3, 4, 5. That's my first leg. Plus 1, 2, 3, 4, 5, 6, 7, 8. That's my second leg. Equals c squared, because I don't know my hypotenuse, because I cannot count it.
So then do you solve?
Then last step, solve for the hypotenuse. What are our steps for using the Pythagorean theorem? Yep, you're going to substitute the numbers. We did that. I'm going to simplify with my calculator. I'm going to solve with my calculator. I'm going to add them together. In fact, simplifying and solving goes together, correct? And last step is square root. So this problem, because it's the hypotenuse, I'm adding them together. 5 squared plus 8 squared. And then the square root of 89. It's going to look weird. That's my answer?
No, you have to like do the little conversion.
I have to convert it.
9.43.
9.43. Approximately, right? Try it again.
Oh, this is actually pretty decent.
I mean, it's not terrible. You've done worse. Zero, 4. -7. Ooh, -7, -9. Doesn't have to be beautiful. Does this remind anybody else, any of something else that we've done this year? Starts with a S and ends with a lope.
Slow.
Yeah. Counting, rise over run, up and over between 2 points. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What? Oh no, you're right. Whoopsies. It's okay. Here we go. My bad. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that better? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Could you do 11 squared plus 9 squared? Yes. A and B can flip-flop back and forth. So 9 squared plus 11 squared. Square root of 202 is the square root of 202. Oh, convert it. What's your answer? 14.21. You're about to find out.